Hello everyone, my name is Rafael. I'm the leader of the Structures and Aerodynamics department at Antares Unicamp, and I'm here to present to you all for the Latin America Space Challenge 2021 our project Aurora, the 1000-meter apogee rocket. For the Structures and Aerodynamics subsystem, we're going to use a von Karman nose cone, a fuselage made out of carbon fiber and a fiberglass coupler to unite the two sections, and a trapezoidal carbon fiber fin set with an airfoil profile. Here are some of the airframe dimensions. To improve the aerodynamics of the rocket, we're going to use a nose cone with the von Karman profile. We're going to use a tail cone and a rail guide with an airfoil profile. The fuselage is going to be laminated over a PVC pipe for internal diameter using epoxy resin and hardener. We're going to cut open the fuselage and stick back using carbon fiber. The tools used by the team were MATLAB, OpenRocket, Creo Parametric, NACA combustion chamber sheet, the thrust curve tracer, the Autodesk CFD software, and ANSYS. The final state of the project is the one shown here using the last data from last simulation performed on Open Rocket. The propulsion subsystem consists of a 6061 T6 aluminum combustion chamber with an inner insulation of fiberglass that is going to protect the combustion chamber from the high combustion temperatures. We're going to use a steel nozzle with a stainless steel 1045 nozzle, which is going to be screwed to the combustion chamber and a hemispherical top to reduce stress. The burnout characteristics are the ones shown here, and it is important to mention that this is the highest impulse class motor that Antares ever developed, which is a Class J motor. The inner insulation is a big cylinder made out of fiberglass, basically. We're gonna use fiberglass because of its low cost and high efficiency, and this material was tested in a flame test among many materials and selected there. Here's a picture of the flame test. We just put a torch and measure the temperature on both sides of the material. The propellant is a base geometry propellant with 65% potassium nitrate and 35% sorbitol. We're going to use around 850 grams per launch, and it's going to be one whole grain molded inside the insulator. The ignition system is a wire ignition system with a composition of ignition powder of 17% activated charcoal and 83% potassium nitrate for the ignition. The combustion chamber was exhaustively tested with stress simulation tools. Here are the dimensions of the combustion chamber, and this combustion chamber is currently undergoing static fire tests. Here are the nozzle dimensions and a technical drawing of the nozzle. The recovery system consists of a octagonal-shaped parachute with the biggest diagonal of 1,500 millimeters. The material is going to be ripstop nylon 45 because of its low mass surface density. We're going to use H-throw lines, a efficient swivel to prevent torsion. We're going to eject using an explosive crimson powder charge and a fiberglass protection plate on top of the parachute. The expected packed length is 230 millimeters. The expected cost for the whole project is around 4,000 to 4,500 reais, but the team's partnerships with many companies help reduce the cost drastically. Now, Gustavo Reis, the leader of the electronics department, is going to talk about the payload and the avionics of the rocket.
Electronics area was responsible to design and build the avionics and payload subsystems. The avionics is responsible for collecting and processing relevant data to the rocket's general operation. Our project uses an altimeter to detect the flight states and to release the parachute during the recuperation phase, and GPS and buzzer to easily locate the rocket on the ground, an SD module to keep all the collected data for further analysis, and the LoRa module to real-time communication with the ground base. To control and process all of it, we use an ESP32 microcontroller. The payload module includes sensors that will help the team to understand better all the flight features and phases, allowing a detailed study over reached velocity, acceleration, trajectory, and temperatures. Therefore, the payload includes gyroscope, accelerometer, thermocouple, string gauge, in addition to batteries and an SD module to store accurate data.
We would like to thank you all for watching, and we hope to perform our best at Latin America Space Challenge 2021.